assignment. Let's do this. All right, from yesterday. Let's throw them out real quick before we move into today's notes. Real quick. Anybody? Henley, start it off. 3B. 3B. All right. If you don't have your calculators out, get your calculators out. Let's talk about those calculators. So right now, my algebra 1s, okay, they are probably more at depth at least their graphing calculators than you guys are in the geometry class you guys are in. My algebra 1s, right now, we are rocking and rolling through absolute value functions, and they are probably more at depth using their graphing calculators than you. So let's make sure we are typing those in correctly and getting those values right there. So on 3B and 3C that Henley's asking about, those are nice ones right there to make sure that we are using those calculators correctly. So on both 3B and 3C, again, as I work through this one and put that one specifically out there, it's really 3C that I want to talk to you about, as he can ask that same one there. All right. On 3B and 3C, we're going to evaluate here with G of 10. But the key on both of these is making sure that you're watching out with that negative out in front, particularly on 3C. As we've gone through and reviewed with you guys over this course this year now, we know our issues are back in that 6th, 7th, 8th grade areas. And backfilling in all those kind of prior knowledge skills. And watching with that negative out front, and here also with that negative. So as you are sitting there, type those into that calculator. You better use those parentheses. As we've gone back to first semester, okay, and talking about when we deal with the Pythagorean theorem, we deal with that radical work, those parentheses, using those or not, will definitely kill you. So what you've got on your paper is we evaluate this, punch it in. Don't wait on me, all right? Punch it in. When you have that lead out there that's negative, we use that enter key, that to the left of the enter key, that negative out front, then that parentheses, and then squared, and what is it? Plus 3. Thank you, Grace. That's where I'm getting a negative 97 out of. Now there's only one negative hiding right here because only that 10 is getting squared in that parentheses. Only it says x squared, that negative out front. Now on that second one, letter C, that is saying take that negative 10 and square it, but there's 3 negatives hiding right there in front of you. There's a negative here and 2 negatives right there. So what you want your calculator to correctly do then is, again, don't get lazy on us. What is exactly on your paper there, better go exactly right into your calculator as well. Don't take the lazy route on you, because we want to take that negative and then square that negative 10. So there's 3 negatives there. We all know 2 negatives make a positive. That's correct. But those 2 negatives making a positive is happening right there inside of those parentheses. Those dang exponent properties from 6th grade is what's hiding right here from them. Now, we can only do so much backfill throughout the course of our geometry classes here, but that's usually what kind of slows us down as we do prepare you for Algebra 2 next year. Okay? So negative 97 is where I'm getting that value as well. Okay? Good question there. That's really more of a calculator use off of that. Keep going. Other questions you guys got from last night? Shut them out. This is your time. Go ahead, Henley. Which one? 9. Let's flip it around. Let's look at number 9. Okay, number 9. Wherever number 9 is. Where happened to number 9? Where did my number 9 go? There it is. You said 9, Henley? Yeah. All right. This number 9 here. All right, first thing we notice is it has to solve by factoring. So using our factoring skills as we've gone throughout this year and added in with you back in December. Okay, first thing is it's not set to 0. Move that thing around, put it in standard form. So as we move that thing around, set that in standard form. R squared, use those algebra skills of yours. 14R, add 49. We're in our standard form then. Okay, Grace nodded her head like she's falling asleep on a thing, or she's passing out the leaves off. She wanted to. Okay, now that we have that, A is 1, B is what? negative 14, and C is 49. So we go to our factoring skills, and we list out the factors of A and C, and this is old habits. Okay? From here, what this one is ever so slightly, this is what we call one of our special cases of factoring. Typically, we get how many solutions? Correct. Typically, we get 2 solutions in quadratics. But as I'm looking at our solution up there, well, we're not actually getting 2 solutions off of this one. How many solutions do we have up here? Correct. We only had 1. And the reason we're only getting 1 off of this is when you guys go about factoring this, well, what do we end up with? 7s, correct. To get that negative 14, as you're checking your guess right there, that's where I'm getting that negative 14. But when we use our zero product property, thank you, you get 2, but what are you noticing about both solutions? They are the same. You don't need to tell me, hey, both of them are 7. I got you. I heard this first time. But that is an instance where we get actually 1 solution. And that's going to tie us back into some of the graphing we've been seeing as we backfilled you. And I don't know if I have a picture of a quadratic on here on your homework. I kind of do. It's not the same graph, but it's this right here. It's when it's representing that vertex. That's where we get 1 solution. And if we had that time, we connect it, but throughout the 2 teachers are going to take you that next step next year. Okay. Good question off of that one. Anything else you guys got? This is your time. You good, Heaven? All right. All right. Heaven says you're good, so let's make sure your name's on it. Throw the basket. Let's get those notes out. Let's continue on here. Since that takes more than 30 seconds, you don't have to do it. So, letter A. Is that a function, yes or no? Yes. Using that vertical line test, do we hit it at more than 1 point? No. So we are a function, right? Letter B, we call that mapping diagram. Kind of looks almost like a table, right? Function, yes or no? What's screwing it up? That sounds good. Right. Q is going to where? Y and Z? Yeah, can't do that. Okay, cool. Take number 2, letter A. We're going to add in some new pieces today. Continuous increasing. All right, that's fine. Who cares? But you all can tell me that's a function. You can be domain and range. We'll do that now. Take 30 seconds to letter A. Go give me the function. Go give me domain and range. Good. Just letter A. Yes or no on function, and then give me the domain and range. You all can do that. Now again, when we talk about analyzing functions, there's several key components as we analyze functions. And one of the very first components you guys will talk about is domain and range. Next key component we start talking about is right here, increasing or decreasing. There's a few other ones that we'll talk about. And I say we talk about, that's not true. You guys, magic number is 34 today. But when we leave here, throughout the 2 teachers, we'll add on 2 more characteristics of analyzing functions. I'm laying the groundwork for you, so make sure we run into algebra 2. She did the ground running pretty well at algebra 2 teachers. All right, number 2, letter A, function, yes or no? That's a yes. Okay, domain, which values are we focusing on, X's or Y's? X is left to right. Okay, on that domain, left to right real quick, do we see a clear starting left value? No, so where are we starting that off at? Sounds great. Negative infinity, comma, sounds even better. Infinities always get a parentheses, thank you. Bottoms up, people. What are we doing? Do we have a floor? What's my floor at? Do I have a ceiling? So if I have no ceiling, what are we doing? Infinities always get a -2, it depends, but we get a bracket. All right, that sounds great. So you guys have, again, over the last couple days that we've kind of crash course you on domain and range here. That sounds cool. All right, take your pencil. Plus, nope, that was just the young consider. All right, continuous. Take your pencil. Can you trace that graph without picking up your pencil? Yes, no. So, would you think this is considered continuous or not? Don't overthink it. I know sometimes math seems like it's super crazy difficult. Sometimes it is, but sometimes you overthink it. So, you all shook your head, yeah. So, would you say this is continuous? All right, that's it. We're good. Okay. Yeah, this is a continuous graph. Then. If you can take your pencil and trace that graph without picking it up, then we say that graph is continuous. Nothing crazy. All right, now let's get into the one characteristic of analyzing that students usually have some issues with, which we call increasing and decreasing intervals. First thing is, it's always coming from your domain. Ignore the range, it's always coming from your domain. All right, pick that pencil back up. We read from left to right. Trust your eyes. What are your eyes doing first on this graph? Your eyes are what? Going down. So let's label it. Your eyes are decreasing. Your eyes are decreasing, and eventually what do your eyes start to do? Stop and go up. They start to increase. But where do they turn and increase at? At where? We're focusing on the domain. There we go. And that's the common mistake everybody wants to do. Your eyes kind of draw down at the -2, but you got to focus on the domain. Let's draw this in. What I just drew in, go back to our geometry topic. That line that I just drew in, we call that line the what? Anybody? I think I got some axis. There we go. Yeah, axis of. Anybody? Axis. If I draw that right down the middle, I can pull it nicely from the left to the right. Yeah, we call that symmetry, symmetrical, right? So we call that the axis symmetry. And right there, that x equals 2, where Grant corrected himself on, we can fold that left to the right. Right there, that x equals 2, that's that sweet spot. Right there, that x equals 2 is where that domain is where we're going to kind of cut it in half, split up that domain, and say, hey, this interval is where it's decreasing, and this interval is where it's increasing at. So now what we want to do then is, as you said, it turns at 2. What are your eyes doing? They now increase, right? Take it from my years of doing it. Literally put that onto your graph, okay? Right where it decreases, put that x equals 2 there, and then right where it increases, just like I did there. Now let's take our interval skills, and let's write it down below. Where was it decreasing from? We're calling from the domain. So we're starting way out here, where? At -infinity. We're looking at the domain, comma, -infinity. And Grant, where'd you say it turned at? 2. Where we put that axis symmetry in is where I cut it. And then we pick it back up at that increasing, and what did it start to do? It kept increasing at 2 and 3 and 4, and where does it keep increasing to? There we go. And if you could, take these two intervals and smash them back together, you always recreate the domain. Okay? Now, infinities always get a parenthesis. I'm going to throw a small curveball to you. We set up above, those always get brackets, right? But at the 2, it's going to actually get a parenthesis because at that 2 where it turns, because that's the turning point, it's neither doing the increase or the decrease then. So we usually put a parenthesis right there because it's not really doing one or the other. That's where that turns at. So that's where we're going to put a parenthesis at that point. That's when we do it on the increasing and decreasing interval. Okay? That's one down. I don't expect you to have that mastered yet. Let's do the second one. Okay? All right, take 30 seconds to answer our part B for me. Do the function, domain, or range. And then do the continuous. Then we'll talk about the increasing, decreasing, because that's the new part for today. But continuous is not crazy, is it? Give me a second. 30 seconds. putting the white past up by then. We are rapidly increasing temperature-wise since yesterday. All right. Function, yes, no? Okay, domain. Is the domain the same as the previous one or not? Is the range the same as the previous one? Yes, no? Definitely not. Okay, bottoms up, people. All right, on that range, do I have a, what? Do I have a floor here? No, so if I have no floor, where are we starting at? Yeah, my knees are getting old here. So, we're starting way down here at negative infinity. Do I have a ceiling then? Where's my ceiling at? And 4 gets a, cool, and then continuous. All right, that's nothing crazy. All right, so let's look at our last one there. It's coming always from the domain. Trust your eyes right on that graph. What are your eyes doing first from left to right? Increasing. So literally, we'll write that on that graph. Grace said our eyes were increasing. And wherever they turn, that's at that axis of symmetry. So again, I would draw in that axis of symmetry. I can't stress to you enough, next year when we talk about analyzing quadratics, that axis of symmetry is going to be such a huge component to that. Axis of symmetry is at where today? It's back at x equals 2. And what's our eyes doing after that? Decreases. Now we're pulling it again always from the domain. All right, we're starting out here from left to right. You said we were increasing first. So from that domain, negative, and where did you say we split at? And right where you split at, pick it up at the decreasing interval. To where? There you go. Okay. And we always use parentheses to correct on the intervals. Exactly it. Boom. Now let's walk it backwards real quick. I keep saying that these are part of the what family? These U-shaped graphs are called part of our what family? Quadratic. Okay, so let's come back around and say these are part of my quadratic family. In Algebra 1, our backfill that we keep doing throughout the year, these are part of our quadratics. Again, what we expect from you guys, hey, we say quadratic, you should see that U in your head, you should know it's x squared and all three of those things, vice versa. Okay? All right, let's throw a little bit of a different graph in there to you. Take letter C now. Same deal. Take letter C, answer out those first few questions that we've been doing. We'll do increasing and decreasing together. Function, yes, no, domain and range, and continuous. Go. Go, go, go. So much cool out there, guys. Now, it's a bit of an odd graph, and we haven't necessarily ran into too many of these just yet, so let's do that. All right, the domain on this one is going to get from what we talked about yesterday. I think we talked about it where we had a union symbol in one of our questions. We're going to bring that into the domain, but we'll deal with it in just a sec. Function, yes, no? Yes. Okay, not as many yeses on that one. Take your vertical line test, drag it across. Is that hitting at more than 1 point? Yep, we're good to go. So let's do that domain. Left to right. We're starting clearly at -2, and then we're going to 0. But then what do we have? We've got a gap, don't we? We got some dead space. When we have a gap there, we got to close that interval we started. They both are brackets, aren't they? So we got a gap, and we got to count for that gap. And the way we count for that gap, again, I think we saw it yesterday. I threw that out there. We don't really encounter very much in Algebra 1, but as we move to Algebra 2 next year. Where do we continue on at then after that gap? Where do we start off at after that gap? I'm sorry, 1. And then after 1, where do we continue on to? 2. So treat those as just kind of 2 separate intervals joined by what we call as that union symbol. Nothing too crazy. And we like to just throw some extra things out there, just a small extra step for you. All right, range, bottoms up. What's my bottommost Y value there? Negative what? 5, and then up, 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 up. Now, my first hour was saying, am I going to do that same union symbol as I did up on that domain? But as I start working my way up, okay, as I keep my eyes left and right here, do I have any gaps, though, between the graphs? Sydney's shaking her head no up here. As this graph stops, the one on the left just continues up, though, doesn't it? So, but do I have any, again, gaps in between the graphs, though? No. So on the range, then, I just continue on from -5 up to 4. I don't need to use that union symbol because, again, there was no graphs from the range, was there? And what is -5? Bracket or parenthesis? And 4 is a, cool. Continuous, yes or no? Correct. I got to pick up my pencil, don't I, to trace that graph. All right, and then let's trust your eyes. What's your eyes doing on this graph? What's the first thing doing? Increasing. What's the second thing doing? Decreasing. Cool. And now, on this particular one, again, we're got a little bit of a change to this one, no big deal. We've already got basically our 2 intervals done for us. Up there in that domain, we're always pulling it from the domain, where we've identified from -2 to 0, that was the only piece that was increasing, wasn't it? So we can just essentially copy paste that on down, okay? So go ahead and copy paste that on down, and I'm fine with you just continue to use those brackets because that either point was that turning. And then for the decreasing, where was that going for decreasing? Yeah, heard somebody say 1 to 2, and same thing there. All right, let's go with one more here, and then we're going to flip it. Letter D. Letter D there. Function, yes, no? Yes. Now, what actually, we've talked about this graph before. We haven't, what's that? Great. We haven't done it in class, but we've talked about it enough times of, it's one of those weird in-between algebra 1, algebra 2 functions that as we've gone through here, we backed it a little bit. Grace said that is the, again, what's that, Grace? That's my square root graph, square root function. Okay? All right. Let's do the domain. What's my domain here? From left to right, what do we got? To what? To 4. Yep, sounds good to me. And what's my range? -infinity to 0? Almost. For the range. Bottom up.
Oh, 0.
There you go. I got you there. So Alexis made the mistake that I see every once in a while. So Alexis said, I'm going to use Alexis as my example here. Thank you, Alexis. So Alexis suggested this, and this is the common mistake I will see quite a bit. Your brain just is kind of hardwired to go like this, go top down. But I keep trying to use that phrase of bottoms up, okay? So floor, ceiling, bottoms up. And then she corrected herself and said, what, Alexis? 0 to infinity. Very nice catch there, Alexis. So again, you want to go bottoms up, negative to positive, and as she then said, 0 to infinity. So watch yourself on that range. That range is always the pesky one to always kind of make that mistake on. Cool. Can we trace it? Is it continuous? Yes, it is. And trust your eyes. What's your eyes doing here? Left to right? What's your eyes doing? Decreasing, yeah. And are we going to increase at all on this one? No. So just kind of scratch it out, okay? And then we can just, since we're not having a increasing interval, that domain, just we can copy paste that on down as well. Okay, so go ahead and let's just copy paste that on down because from here to here our eyes are going down, and we can call it a day. All right, for our time here, we've got a nice little practice in there, so let's go ahead and as I see Sydney flipping it. As we keep talking about these functions here, and as we keep doing a little bit of work then, let's talk about a little bit of SAT then with our functions use. When you look at this next problem here with our functions, this is what we call, again, we've been backfilling some stuff, this is what we call a linear piecewise function. Now my Algebra 1 kids, my sophomores, you guys had this last year, we talked about a linear piecewise. Why do we call this a linear piecewise function? Don't overthink it, because it's a whole bunch of linear pieces, right? So let's take it. These are good SAT style questions that I've modified it here. Okay, read through this graph. We've got this hike going on between Sarah and Chelsea. What was the total distance of that hike as you read through there? Take a minute, read through that question. And then, how many hours did it take? What were Sarah and Chelsea doing from points D to E? Are any points similar? What was the shortest for Sarah and Chelsea? And there's that word rate and change. We'll give you a minute here on your own. And then after that, if you answer up those questions and have you turn to a buddy like you do, and have you try talk turn with your buddy, you guys get the same answers, yes or no. Okay, before I tell you to turn to a buddy here, the one thing I like to stress on this is we're working with first hour. Making sure you are absolutely reading that scale correctly. Okay, our scale is going by halves there, and making sure you read H's ending at not 14 but 14 and a half, right? Making sure you're reading that carefully. So let me give you about 2 or 3 minutes here. Turn to the buddy then, and let's look through that. Okay, confirm with your buddy. Okay, go. Turn to the buddy here real quick. Check this.
Oh, yeah. Okay. Yeah.
No problem. Hopefully it's clear where you're going. Yeah, I know. You know where you're going then? About one more minute here, so keep moving. So, what is 7 a.m., 8 a.m.?
Oh, yeah.
What's that?
That's a lot for hiking.
Some people love to hike.
Those people are weird. Oh, my hike was gonna be a 10-minute hike max.
All right, let's go through this so we can watch the time here, guys. See, total distance of the hike. Anybody? Started off at like 7 a.m. here, 0 kilometers hike because we hadn't started yet, and eventually by 14:30, we had stopped at point H and had done 16 kilometers. Right? How many How many hours did it take? 7.5 hours. Right. From 7 a.m. to 14:30, that is a difference of 7.5 hours. Okay, so on points D and E, D to E, we've got 3 of these, and what we call these horizontal lines, my sophomores should know it, we are increasing, 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 increasing. Here at the horizontals, we call these constant. You're not increasing, you're not decreasing, we say they're constant. What's happening at those 3 intervals? They're resting, they're taking a break, they're doing something, but they're not hiking anymore, are they? Okay? As you take a look at their distance right here, as we can see from 7 to 8:30, their distance is increasing, but from 8:30 to 9, it's staying flat at 4. So yeah, they're no longer hiking, they're resting, they're maybe at a lake or something, taking a picnic, whatever, but they're not hiking anymore. And we know there's a few other intervals that are like that, B to C, and F to G. And what of those is the shortest one? And that's only a short interval of 30 minutes. Now, when we say rate of change, that's a fancy word for saying find me the, ratio or the slope, right? So for 9 to 10:30, where's 9 to 10:30? Okay, find me the slope. That's what we're doing, the rise and run. Watch your scale. From 4 to 8, that's a change of 4. From 9 to 10:30, okay, Grace was saying, she wasn't necessarily seeing like that half. This is where that half is coming into play. From 9 to 10:30, from 9 to 10 and a half, that's a change of 1.5, isn't it? So how do I write slope? Rise over run. So 4 over 1.5. Clean that up. We never leave decimals and fractions together. Let's go to your calculator. Calculate your buddy. 4 divided by 1.5. It is not, I believe, pretty. So we use our calculator and change it to math fraction, which is, somebody get 8/3. So what does that mean? It means in that span from 9 to 10:30, they are hiking about 2 2/3 kilometers per hour. Okay, they're hiking about almost 3 kilometers an hour. That's what they're doing in that span of time. Okay. All right, let's flip it. Let's talk about the backside. I want to do one more part. I think your guys are pretty good on that last question. I got some extra questions there, but the last one I'm going to do here is the graph part with you real quick. On number 5, from the graph, letter A, when I say f of 0, what are you going to return from me? When x is 0, where's the y value? 1. So again, you're looking at the graph. When x is 0, where's the y value at? Yep, x is 0, the y value is at 1. Once you get these underneath your belt, you're pretty good. It's the second part that I want to talk about again. F of 1, when x is 1, the y value is? Yep, 0. F of 2, x is 2, y is? F of negative 2. Whoops. X is -2, Y is -3. Again, those are usually not my issues. Might make mistakes the first time through, but they usually get fixed pretty quickly. It's the last three questions there. You gotta train your brain. Look at the y-axis. When y is 1, y is 1, x is what? 0, right? When y is -3, when y is -3, x is what? 2 are typically in a quadratic. How many solutions do you get? 2. Make sure you count for that. The only exception to that rule is right there at that point. We got one solution. We call the vertex. That's that exception to that rule. When y is 0, y-axis is 0. What's my solution? X is 1 or, there we go. X is 1 or -1. Okay? All right, that's where we'll leave it for today. Let me get you assignment out. Now, one more time, is anybody going to be gone, say, tomorrow, Wednesday? I'll be on, get you here in a second.
I want to get Anna. We're not going to do it. No. And Dad looks like Jack Black. And then we'll get back at like 3. And that is silly. I'm gonna tell him that. Oh wait, run on.
Anybody else going to be gone tomorrow?
He is gorgeous. He is a gorgeous dog. You're going to water
Tuesday, Wednesday.
We're gonna get that tattoo on myself. I can't tell that always. Me like to see him.